But today we are going to continue with law of signs. If you were here yesterday, I did mention that there was a case that we were just covering today that we didn't cover yesterday. So you can use law of signs to solve a triangle if you are given two angles of a triangle and one side. So all of the triangles you were solving yesterday in class or on the assignment, you were given two angles and a side. It's also possible to use law of signs if you are given two sides and then the angle opposite one of them. However, when you are given two sides and an angle, it is possible that there are 0, 1, or 2 triangles that could be created. So it's possible that the sides you're given with the angle, that information together can't physically create a triangle. So there would be no solution. It's possible that it could create exactly one triangle, and then you would just solve it like we did yesterday. Or it's possible that what you're given could really create two different triangles, and then you'd have to solve both of them. So this box here, you do not have to have this information memorized, but you have to know how to use it to work with law of signs. This lays out the possibilities you have, how you know if you have 0, 1, or 2 solutions. So we're considering a triangle in which A, B, and the measure of angle A are given. In some of the examples, you will not have the triangles given to you in terms of A and B and C, but I'll show you kind of how to relate it to these formulas that are in terms of A and B. So first of all, if the angle A you are given is acute, you have these 4 possibilities. First of all, if an angle is acute, what does that mean? Smaller than 90 degrees, still greater than 0. So this would mean A is between 0 and 90 degrees. If angle A is acute, first of all, then you look at the two sides you're given, A and B, and you want to see if A is smaller than side B or larger than side B, or equal to side B is a possibility as well. If your side A is smaller than side B, then you need to find the height h of the triangle. And we'll talk about how to find that. We can find that using a trig function. But you would need to find the height h of the triangle. And this lays out, comparing A to H, how many possible triangles there are. So if you know, for example, A is smaller than B, and then you find H, and A is also smaller than H, it is physically impossible for those two sides in that angle to create a triangle, so there's no solution. And this does show a visual representation of that, what side A would look like compared to side B. And even if you dropped this side down to line up with the height, A is still too short to actually create that triangle. So no solution. If A is less than B, and then you find H and A is equal to the height H, then there's one solution. That would mean you have a right triangle. And then if A is less than B, and you find H and A is greater than H, so they wrote it on here as A being between H and B, smaller than B but larger than H, then there's 2 possible triangles that you could have. So one possible triangle would be how I highlighted this in yellow here. So this would be side A, and therefore, given where side B is, this angle down here would be side B, and B would be an acute angle, smaller than 90 degrees. Or you could get a triangle if A, think of this side kind of as swinging over to here. This could also be the triangle that's created, in which case this angle, the rightmost angle of that triangle would be angle B, and in that case, angle B would be an obtuse angle. So there's 2 separate triangles, And without knowing more information about angle B, you don't know for sure which one you have. So you would have to find the solution or solve each triangle so that one question would have two possible answers. And then if A is not smaller than B, so if A is either equal to B or larger than B, there's only one possible triangle. And then you would just solve that like we had yesterday. So that's all if A is an acute angle. If A is a right angle or an obtuse angle, so 90 degrees or larger than 90 degrees, then it's possible to have no solution or one solution, and all you have to do is compare A to B. So if A is less than or equal to B, there's no solution. This kind of shows why here, given the length of A compared to B and the fact that A would be obtuse or right. It's impossible for the side length A to reach down far enough to actually create a triangle. And then, what was that?
Like tip B that way, then A would touch.
Right, but then you would be changing angle A, and A would be, yeah. So it's basing it off of A. This is if A is right or obtuse, then it's not possible. And then if A is bigger than B, again, A is either 90 degrees or obtuse, then it's possible to have one solution. So the only way you're going to get two different solutions, and that is what the ambiguous case is if your A value is larger than B or smaller than B, A is greater than your height, and then your angle A is acute. So we're going to work through, I have 3 examples, and again, this chart you don't have to memorize, but you need to know how to use it. So how to get the information to then use that chart and answer the questions. Also, if you need to find H, your height, since if you just look up here, when we drop down that height and create this right triangle, sine of angle A would be opposite over hypotenuse, so it would equal H over B. That's where this is coming from. Therefore, if we solved this for H by multiplying each side by B, to find H, you can use this formula, B multiplied by sine of angle A, and that'll give you your height in your triangles. So for each of these 3 examples, we're going to determine, is there no solution, one solution, or 2? And then if there's 1 or 2 solutions, we'll find them. And any side lengths round to the nearest tenth, any angle measures round to the nearest degree. So for example 1, we have triangle RST. We're given angle R is 95 degrees, side R is 10, side S is 12. So like I said, you might have questions that are not given to you in terms of A, B, and C, but to relate what you're given to what this chart states, notice in the chart, you're given A, B in terms of sides, and then the measure of angle A. So with this information, we can think of angle R as being angle A when we're looking at the formulas above. That means side R would be side A, and then side S would be side B. So that way you can, again, compare it to the formulas you have. So first of all, look at angle A. Is it an acute angle, a right angle, or an obtuse angle? Obtuse. It's greater than 90. So then that means you are looking in the rightmost part of that chart. We're either going to have no solution or one solution, and it depends on if our side R is either smaller or larger than side S. So because R is 10, S is 12, R is less than S, which would be equivalent to A being smaller than B. Looking at our chart, if A is smaller than B, for angle A being an obtuse angle, there's no solution. So there's no solution for number 1. It would be physically impossible with those 2 side lengths and that angle to create a triangle, right? Well, you could do that, but then this would have to be angle B. So in the triangle, this side R has to be the side that is opposite angle R. So you could say this is B, this is A, but then this would have to be angle B, which then you'd be thinking of angle B as angle A if you're looking up here. So however you kind of pair the variables, it would be no solution there. Other questions on example 1? Okay. And then in example 2, we have triangle MNP, and we're given angle N is 32 degrees, side N is 7, and side P is 4. So because we're given angle N, again, thinking back to the formulas we have, I'm going to think of this as being angle A. When we look at those formulas, meaning side N is side A, and then side P, we could think of as side B. So angle A, acute, right, or obtuse? Acute, less than 90. So if we have an acute angle, you have to then, again, compare your two sides. So in this case, we want to know is N less than or greater than P. So 7 is bigger than 4, so N is greater than P, which would be equivalent to side A being larger than side B. So if you look back at your sheet, for an acute angle A, when A is larger than B, there's one solution, one possible triangle. So we know there's one solution for these two sides and that angle. And then if there is a solution, you need to find it. So now you're solving the triangle just like we did yesterday, using law of sines to help. So I'm just going to sketch the triangle. I want to make sure, usually the angle I'm given when I draw a triangle, it doesn't matter where you put it. I usually put it in the lower left, so I would call this angle N. And I want to make sure, because I know angle N is acute, that when I'm drawing it, I try to draw it then as an acute angle. So this is 32 degrees. The side opposite angle N was side N, and we know that is 7. And then it doesn't matter which other side you label as side P in this case. Typically the other side I'm given, I label as this leftmost side. That's just typically how I label it, but if you put it as the other side, you're not going to get a different answer. But that means then the angle opposite side P, so this lower right angle would have to be angle P. And then the only other angle I have left would be angle M, and then across from that would be side M. So to solve the triangle, we're finding what we don't have. So we don't have angle P, we don't have angle M, and we don't have side M. We need to find those three things. And we can use law of sines to help us out. So as a refresher here, for law of sines in this case, it would be sine of angle M over side M will equal sine of angle N over side N is equal to sine of angle P over side P. And look for the full ratio that you have. So what angle do you also have the opposite side for? We know angle N and side N. So that ratio we already know. So I know that sine of 32 degrees over 7 will be one ratio. And then based on what else we are given, what are we going to have to find first? Angle P, because we know side P. We can't find either angle or side M without knowing at least one of those two things. So we can find angle P, so sine of angle P, which we don't know, over side P is 4. And solve this proportion to find angle P. So set the cross products equal to one another. So 7 times sine of P is equal to 4 times sine of 32 degrees. And then trying to solve for P, so divide each side by 7. So sine of angle P is equal to 4 times sine of 32 degrees divided by 7. And if we have sine of P, and keep in mind you're trying to find an angle, how do we solve this for P? Or what do we need to do to find the angle P? How do you cancel out sine? Yep, the inverse, the sine -1, the inverse sign. So if we take inverse sine of each side, that means angle P is going to equal inverse sine of this whole quantity, 4 sine of 32 degrees, all divided by 7. And now I know different calculators all work differently, but some of you have a calculator where you can just type this in the way that it looks. And if you are following along with this and not getting the right answers on your calculator, let me know during work time. I'll help you out there. But typing this in, so sine inverse, or inverse sine, so second sine, and then I can type in 4 times sine of 32, close that parenthesis for the sine of 32, and then divided by 7, and then close the parenthesis for the whole inverse sine quantity, and hit enter. And it's about 17.6. So angles you want to round to the nearest degree. So you'd round this up to 18 degrees. So angle P is about 18 degrees. Any questions how we found angle P? Okay, now we still need angle M and side M. What would we need to find next? Or what can we find next? We can find angle M how? Yeah. Or, yeah, adding 32 and 18 and subtracting from 180 because we know two angles already. So 180 minus 32 minus 18 is 130. So angle M is 130 degrees. And now that we have angle M, we can use law of sines to find side M. So I'm still going to use that ratio with angle N and side N because that was what I was given. When we found angle P, that was an approximation. So I have sine of 32 degrees over 7 is equal to, and sine of M will be sine of 130 degrees over side M, and then solve for M. So cross product, set those equal to each other to solve for M. So M times sine of 32 degrees is equal to 7 times sine of 130 degrees. And divide each side by sine of 32. So overall, to find side M, we are taking 7, multiplying by sine of 130, and then dividing by sine of 32. And side lengths, you'll round to the nearest tenth, so about 10.1. Taylor?
No.
You cannot. Why not? It's not a right triangle. That's a good question, though. Second hour had that same question, why we can't just use Pythagorean theorem. So the whole reason we have law of sines, and we'll be covering or starting at least law of cosines tomorrow, these laws exist in order to solve triangles that are not right triangles, since Pythagorean theorem only works for a right triangle. And so do the trig functions we know, sine, cosine, tangent. To use that to find an angle, unless it's part of law of sines or law of cosines, you also need a right triangle for those as well. So this is our answer. One possible triangle, and we solved it by finding what was missing. All right, so then in example 3, we have triangle ABC. We are given angle A is 47 degrees, side A is 15, side B is 18. So angle A, 47 degrees, acute, right, or obtuse? Acute. Do you want to start the next one? And if it's acute, we then compare side A to side B, is A larger or smaller than side B? So if A is 15, B is 18, A is smaller than side B. So as we have stated on the front, there's 3 different cases if A is smaller than B. So in order to figure out if you have no solution, 1 solution, or 2, you need to find the height H. And that formula to find H was here. H is equal to side B multiplied by the sine of angle A. So H is equal to side B is 18 multiplied by sine of A is 47 degrees. So if I multiply 18 times sine of 47, side H, or the height, not side H, but the height is about 13.2. And then if I compare side A to side A to the height of the triangle, A is larger. So A is smaller than B, but larger than H. And that means there are 2 possible solutions, which maybe you figured because we already went through a no solution and a 1 solution. So there's 2 possible solutions here. So we're going to split these up and find solution 1. Solution 1 will be if angle B is an acute angle. And I did briefly mention that on the front. The 2 different solutions are, one, angle B is acute, the other, angle B is obtuse, because both triangles are possible with the 2 side lengths that we have. So if angle B is acute, and you can kind of use the diagram on the front to help you with this. So if I'm sketching out the triangle, I would sketch it similar to the one I had before. So I want to make sure when I'm drawing this that angle A is acute, but then angle B would also be acute. So here's angle A, and I know that is 47 degrees. Side A is across from angle A and is 15. Side B, again, doesn't matter which remaining side you label as side B. I usually label it far left, so B is 18. And that means angle B is across from that side, so that would be the lower right angle. And then the angle inside left would be angle inside C. And this is going to be solved like we solved the last example. So we need to find angle B, angle C, and side C. Based on what we're given, what do we need to find first? Angle B. Because we have angle A and side A, and then we have angle B. So we don't have either part of C, so we can't do anything with C just yet. So we'll have sine of angle A is 47 degrees over side A is 15 is equal to sine of angle B, which we don't know, over side B is 18. And we're solving for angle B just like we solved for angle P in the previous example. So with cross products here, we'd have 15 times sine of angle B is equal to 18 times sine of 47 degrees. Trying to solve for angle B, we would divide each side by 15. So sine of angle B is 18 times sine of 47 degrees, all divided by 15. And then to find the angle, we take the inverse sine of each side. So angle B will be inverse sine of 18 times sine of 47 degrees, all divided by 15. And we'll calculate that. So inverse sine of 18 times sine of 47 divided by 15. And round to the nearest degree, which would be 61 degrees for angle B. All right, and then what can we find next? Angle C, and somebody said it, 72. 180 minus 47 minus 61. And then once you have angle C, you can use law of sines to find side C. So I'm still going to use the ratio with angle A and side A because it was given. So sine of 47 degrees over 15 equals, and then sine of angle C is sine of 72 degrees over side C. And this, I'm going to just kind of skip ahead a few steps in writing this out. So to find C, we're doing the same process. And some of you do this already when you calculate or solve proportions. So C is going to be the product 15 times sine of 72 degrees divided by sine of 47 degrees. So just saving some time here, not writing out each individual step, but then if we calculate that, side C to the nearest tenth would be about 19.5. So that would be one possible triangle created with those two sides in that angle. All right, there is another solution, which once you have solution 1, solution 2 is quicker to find what's missing. But I want to make sure you understand how to get it. So solution 2 is as if angle B is obtuse. And so you can, again, if you flip to the front, you can kind of see what this triangle would look like. Angle A would still be acute. It's kind of a skinnier looking triangle, but angle B is obtuse, so it looks something like this. Angle A is still 47, side A is still 15, side B is still 18. Everything's in the same spot, but you can see the triangle is different. Angle B would be greater than 90 degrees. We still need to find angle B, angle C, side C, but we are not going to find angle B the same way we found angle B in the first solution, because if we did this process again, we're going to get the same answer, because everything, all the values are the same. So here's the reasoning behind what the new angle B is. When you use a calculator to find an angle and you're using inverse sine, inverse cosine, inverse tangent, your calculator is going to give you the angle as an acute angle. And it has to do with what the domain and range of the inverse trig functions are. So when we did inverse sine of this value to find angle B in solution 1, we got 61 degrees. And that means, I'm just drawing angles in standard position here, that means angle B could be 61, or we could have a situation like this, where the reference angle to angle B is 61, meaning this whole angle would be angle B. So it could also be giving you the reference angle. If the reference angle was 61, what would angle B be, or how would you find it? Or yeah, 180 minus 61, and that would be 119. So the other possible angle B could be is 119 degrees. And it's, again, taking 180 and subtracting 61, because 61 could be the reference angle for angle B. So we have angle B. We'd find angle C. Now, the same way we have been, take 180, subtract angle A of 47, subtract angle B of 119. So in this triangle, angle C is going to be 14 degrees. And then to find side C, you would use the law of sines. So I can still set it up the same way we found side C in solution 1, just the angle C is different. So we would still have sine of angle A is 47 degrees over side A is 15 equals sine of angle C is 14 degrees in this case over side C. And then just to save us some time, this would then be solving that proportion, but side C would come out to be the nearest tenth 5.0. And this would be the second solution to that question. Are there